Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Coronagraph Images Show Planet X Interacting with the Sun. Now, a coronagraph is a telescope which blocks the sun's brightness so that the sun's corona can be clearly observed in visible light. The K-Core coronagraph is at the Mauna Loa Solar Observatory in Hawaii. And images provided by this coronagraph show evidence of Planet X system stellar core activity in the sun's corona. Stellar cores are dead or energy depleted stars in the sun's corona. And you may look at article 236 entitled What are stellar cores for more details. And here you see an image of the stellar cores. This is an STO composite image in several different colored filters. And you can see this object moving through the sun's corona. And this object is striped. As you can see, the stripes are curved. They follow the contours of the object because it's a spherical object. Now, this is clearly an object moving in the sun's corona. This particular one was about 4 times larger than the Earth, but there are some that are much, much larger than this. Now, the term stellar core encompasses both dead stars and dead planets. The stars can also be described as brown and black dwarfs. And you may look at article 317 entitled Planet X System, Brown and Black Dwarfs with High Magnetic Field. These objects are often observed in the sun's corona. They have low gravitational influence as a result of their low energy status, and they absorb energy from the sun. The sun is therefore dying as a result of their presence. And you may look at article 195 entitled Stellar Cores and the Dying Sun for more details. Now here you see one of the images from the K-Core coronagraph. And in this image, which is from July 6, 2018 at 17:01 UTC, we see a bright spherical object, which is most likely a stellar core, and I will show that it has to be a stellar core, and it appears on the sun's western side. Now, the concentric ring structure is due to diffraction effects arising from the aperture of the eyepiece on the telescope. And this is what a bright source of light in the distance can look like through a telescope. And this is if it's focused. Even if it's focused, you always get this ring pattern alternating bright and dark rings. And this is due to diffraction, and whenever you have a small lens or small aperture, then you are going to get these effects. There's absolutely nothing we can do about it. And this is if the telescope is properly focused, you get a smaller ring pattern. If it's defocused, then you get a larger ring pattern. And you can also have other effects. These may be because things are not perfectly aligned. Then instead of the ring pattern, you get arcs, alternating bright and dark arcs. Now, when the telescope is perfectly aligned, then it's described as being in collimation. And here are further effects that you can get, and this one is due to atmospheric turbulence. So you can see the ring pattern looks like it's distorted. And here, and this is if it's focused. There's still a ring pattern, but there's a bit of distortion on it. So it's not as clear. And this is for the focused telescope. If it's defocused, then the ring pattern is larger, but definitely still distorted. And here you have further effects. You have uncollimated beam, turbulence, and then the bright object, which is supposed to look like that, turns out to look like this. It looks like a dark central ring or central circle surrounded by this distorted ring pattern or bright ring pattern around it. So we see lots of these, of course, in chronograph images if there are light sources there, because chronographs are, as I said, telescopes. Now this image is from 2040, still on July 6th. As you can see, the object is still there. This is 3 hours and 40 minutes later. And this image is from 2356, and I will show below that the object has moved slightly now. There appears to be another one showing up there, but this means that the object has now been very, very close to the sun, very close to the sun's surface or the photosphere for nearly 7 hours. And here I actually show that this is actually the first two images, the 1701 and the 2040 images. And by drawing a red line across, you can see that the object hasn't really moved. It has stayed in the same position. Now, stars are not bright enough to be observed through the sun's corona. However, if it was possible that the bright source of light observed in the above images was a distant star, we would expect it to have moved to the right and not have stayed in the same position for such an extended period of time. Distant stars appear to move to the right as a result of the Earth's motion with respect to the sun. The inner planets can move to the right or to the left depending on their orbital positions. The sun stays stationary because the telescope tracks it. Anything that remains stationary is therefore moving with the sun and thus energetically bound to it. In other words, it's a stellar core, because we know that these are the objects that have invaded the solar system and are found in the sun's corona, and they are energetically bound to the sun because they are absorbing energy from the sun. And here are the images. This is the 2040 image. It shows here from 2040 to 2042, but I only show, that's because these are GIF images. It's a whole series of images together, but I only show the first one. So this is actually from 2040, and this one is from 2356. And as you can see, the object seems to have moved slightly upwards. If you look where the end of the red line is, or where the red line is in comparison with this bottom first dark ring, you can see that here the red line seems to be closer to it. So the object seems to have moved slightly upwards. And by now it's 7 hours since we first saw it close to the sun. Then a little later, and this is July 7th at 1:49 UTC, we can see the object is no longer there. There are two other objects here, and it may be one of these two objects. This one has a dark center, and this one has a bright center. So it may be more likely to be this one, but I am not completely sure that it is one of those objects. We don't actually know exactly what has happened to it. It certainly was there for 7 hours, and now it's not there. But we can see several other objects in the sun's corona. As we look more and more at these images, we can see what seems to be these concentric ring patterns, not as clearly, but this seems to be more objects in the sun's corona. And these are the smaller ones, and we see the dark centers and the distorted cloud around them, possibly out of focus and not as large as the one that we first saw, and therefore that's what they may end up looking like. But these are objects in the sun's corona. These are not likely to be stars because, like I said, it's very, very unlikely that we will see stars so close to the sun through the sun's corona. So these are likely to be stellar cores in the sun's corona. Now these images, this is the July 6, 2018, and I placed the two images side by side. The first image from July 6 at 1701 and the last image at 149. So we can clearly compare and see what has happened. The object was here, it's no longer there. We can see two objects there. I'm not sure that this object is either one of them, but it's possible that it is. And we can see lots of other objects in the sun's corona that look like distorted ring. They have distorted ring patterns. So there's one there, and there's lots of these small ones here, lots of them. Now these images are from March 6, and what we see is two objects in the sun's corona, also on the western side. And then, so this image is from 1857 and this one is from 1944. And we can see it looks like the two objects are still there, but another one seems to have appeared. And we also see this a little object just above the North Pole that we don't see in the July images. So obviously it was there for a while and it disappeared after a while. You can see it more clearly here. Now here we can also, I have estimated how all these objects have moved. This one doesn't appear to have moved. This one seems to have moved closer to the sun. So has this one, and this one has appeared. So both of these have moved closer to the sun. Then this image is from 2139, so a bit later than this last image from 1944. And this object seems to have moved closer to the sun, definitely, even closer than it was there. So it seems to be moving towards the sun. And here I've drawn a whole lot of lines to estimate how much, how these objects have moved. And they all seem to have moved closer to the sun. So this is the 1944 and the 2115 image. So this one has moved closer to the sun, and so has this one. So you can see the line seems to be closer to the center of the brightest central part of the object. So it seems they all seem to have moved closer to the sun. Then this image is from March 7th, so a date later at 1805. As you can see, the image looks quite different. We do not clearly see the objects. They are fainted, but they seem to still be there. There's this one, appears to be the same as that one. And then this one with a dark center is not as clear, but it seems to be the same object that we see there. It seems to have moved downwards. And then I estimate how these objects have moved. As you can see, this object has moved now further away from the sun. And this one seems to be closer to the sun, but has moved downwards. And this one here, well, that's gone. So these objects seem to be moving around. This motion is not consistent with what we would expect with background stars or any known planet in the solar system. Hence, these are or have to be Planet X system stellar cores interacting with the sun in the sun's corona. So in conclusion, MLSO coronagraph images provide clear evidence of large numbers of stellar cores in the sun's corona. The objects are observed to stay very close to the sun's surface for some 7 hours, and also to move both closer to and further away from the sun. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.